Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Mets. And without any further ado, let's look at these questions that we have here. Okay, so we have in the circuit diagram below, the battery has an EMF of 12 volts and negligible internal resistance. The resistance of resistor R is unknown. When the switch is closed, the ammeter A reads 1.5 amperes. When the switch is closed, calculate the potential difference across the parallel resistors, right? So now we must calculate the potential difference across the parallel resistors. The parallel resistors are the ones that are here on this parallel branch, starting from the 6 ohm and these two combined here. Now we are already accustomed to this way of putting on resistors. We know that every time we are facing this situation, we have to take these ones here and combine them to form one big resistor, right? But then now, if we want to calculate the potential difference across the parallel resistors, we would need to know this resistance, right? And then, so that would kind of pose to us a challenge. But then now, that's not only the method that we can use to calculate the potential difference across here. We do know of a formula that says the voltage that flows in the total circuit or the external circuit is equal to the voltage of the parallel plus the voltage of the series. Now we do know the voltage of the total is 12, and then there is a way in which we can calculate the voltage in the series, since this 3 ohm resistor here is connected in series. Now we are essentially saying that if we can calculate the voltage in the series, take this voltage in the series and subtract it from the total voltage, then we can end up with the voltage parallel, right? So the way to do that is, number one, let's calculate the Vs by saying the current multiplied by the resistance. So the current, we're going to take the current in the 3 ohm resistor and then also the resistance of the 3 ohm resistor. Now, we are given the current in the ammeter, it's 1.5 amperes, which is, this one is indicating the total current. But then since we know that the ammeter and this resistor here is connected in series, then we know that also the current that flows in the 3 ohm resistor has to be 1.5 amperes. Remember, for all the components that are connected in series, then we mainly say that the current is the same throughout. So that means the current in the 3 ohm resistor is 1.5, and then we're going to take that and multiply it by 3, right? Now, if we say 1.5 multiplied by 3, we end up with 4.5 volts, right? So note that this is the voltage in the series part of the circuit. But then now we want the voltage of the parallel. So using this formula, we're going to say the V total is 12, and then we do not have the V parallel, but now we do have the V series is 4.5. So to get to the V parallel, we have to say 12 minus 4.5, right? And then when we subtract that, we end up with V parallel is equals to 7.5 volts, right? And then that becomes the voltage in the parallel circuit, right? Or in the parallel branch. Then 9.1.2 says, now calculate the resistance of resistor R, right? Now, how would we calculate the resistance of resistor R? Looking at this, we can see that using the total current and also the V total, we can figure out what is the total resistance of the whole circuit. So by simply saying R total is equals to V total over the I total. Now our V total is 12. Divide that by 1.5. We're going to end up with, so if we say 12 divided by 1.5, that's going to give us 8 ohms. And then now, if we have the 8 ohms, we can essentially say that the R total, we know it to be the R parallel plus the R series. So the R total is 8. We do not have the R parallel, which is the one that will actually help us to find the resistor R here, since resistor R is in the parallel combination. Then what is the R series? It's 3. So to find the R parallel, we can say 8 minus 3, and then the R parallel will be giving us 5 ohms, right? Now, when we have the 5 ohms here, we can then say, since all of these are in parallel, we will say 1 over Rp is equals to 1 over R1 plus 1 over R2. So we only want to have 2 resistors, because remember, these ones here, since they're in series but then in a parallel combination, then we have to add them to form one resistor. So now the Rp is 5, so we have 1 over 5, and then is equals to 1 over 6. So if we take this one as the R1, and then the R2 would have to be a combination of this. So that's 1 over 12 plus R. Now at this point, we can take the 1 over 6 and transpose it over to this side. So we have 1 over 5 minus 1 over 6, which will give us 1 over 30, right? And then it's equals to 1 over 12 plus R. Now, if we have to cross multiply here, then we end up with 12 plus R, because 12 plus R multiplied by 1 is 12 plus R. Then 30 multiplied by 1 is 30. Now, to calculate our R, that is supposed to be 30 minus 12. Then our R is going to be 18 ohms, right? So we find our resistor R for a total of 5 marks. So all the steps were worth it. 5 marks, guys. So number 1, we get the R total. We find that it is 8 ohms. From that R total, we subtract the resistance in the series, which will lend us to 5 ohms for the resistors in parallel. And then now we do the formula for the resistors in parallel in order to find our resistor R. That's how you were just supposed to tackle that one. Then 9.1.3 says, calculate the power delivered by the 6 ohm resistor. So 9.1.3, the power delivered by the 6 ohm resistor. Number 1, let's look at the formulas for power. We have this, we have that, and then we also have this one. Now, obviously, we must land with the suitable formula. So in order to calculate the power delivered by the 6 ohm resistor, number 1, let's figure out, here we had 4.5 volts. And then we figured out that the potential difference across the parallel resistors, they all give us 7.5 volts. Now, knowing that the potential difference across the parallel resistors is the same throughout, we know that we have 7.5 volts here, and then also a combination of this will have a voltage of 7.5 volts. Now, we can use that, right? We can use the fact that we already know that the voltage in here based on 9.1.1 is 7.5 volts because it is connected in parallel. And then now looking at this, what information do we now have? We have the voltage, and then we also have the resistance, meaning that if we have to choose the formula to use here, the perfect formula to use is the third one, which says P is equals to V squared over R. So this is P is equals to our voltage is 7.5. and then square, and then our resistance is 6, right? Then at this point, if you do that, then it is supposed to give you, punch it in your calculator, it's 9.38 watts, right? So your power is equals to 9.38 watts. And then that's just how you were supposed to calculate that one. Then let's proceed. They say now the 3 ohm resistor is now removed from the circuit and replaced with a conducting wire. So now they're removing this one. So we no longer have that resistor there. And then they're replacing it with a conducting wire of negligible resistance. How will this change affect the ammeter reading, right? Only increase, decrease, or remain the same? And then explain your answer. Now again, if we remove a resistor in series, we know that we are expecting the total current, the total resistance, meant to say, we are expecting the total resistance of the circuit to decrease, right? So the total resistance of the circuit will decrease. But then according to the relationship that we know of resistance and current, we know that resistance is inversely proportional to current. So now if our resistance is going to be decreasing, what will be happening to the current? Remember, ammeter reading speaks to the current. The ammeter measures the current. So what will be happening to our current? That means it will be increasing. In other words, the ammeter reading will increase. So for 9.2, we are supposed to say increase, right? And then what is our reason? Going to say, according to the formula, according to R is equals to V over I, we know that resistance is inversely proportional to current for a constant voltage. So it is very important to state that that happens if we maintain that the voltage is the same, is constant, right? And then now we know that a decrease in total resistance will result in an increase in the total current. So that means at the end of the day, we are expecting our ammeter reading to increase. So that's how you explain this, right? And then we have now 9.3. They say the kettle is rated 2000 watts. Calculate how much it will cost to use the kettle for 5 hours. 1 unit of electricity, 1 kilowatt hour of electricity cost 1 rand 0.02. So now, in order to calculate the cost, we're going to say the formula is 9.3 is cost is equals to kilowatt hour. Multiply that by the tariff. So we have our kilowatts, that's 2000. And then remember, if we are given in watts, the first thing that we need to do is we convert the watts into kilowatts by doing what? Dividing by 1000, right? So that's what we are doing here. So that's 2000 divided by 1000, then multiply by the given hours. So always remember, if it is given in minutes, and then you have to convert those minutes into hours by dividing by 60, right? So multiplied by 5, and then what's the tariff? That's 1 rand 0.02. So now the 2000 divided by 1000 will give us 2 kilowatts, and then multiplied by 5, multiplied by 1 rand 0.02. So now when we do the calculation for that one, we end up with the cost being 10 rand 20 cents, right? So that's the cost of using the kettle that has a power rating of 2000 watts for a minimum of 5 hours a day, right? Then that's just how you were supposed to answer all of these questions for a total of 17 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.